This particular panel is on the role, why the tech companies are interested in ROS, and in particular maybe ROS Industrial. So as I mentioned, Roger Barga, who spoke just recently, the director of the AWS Cloud Robotics Initiative, he's here today in person. Online today we have Joshua Heppner. He's with Intel and their IoT organization based in the Phoenix area, correct, Josh?
Right.
And then Lou Amadio is a principal architect or a development lead in the Windows IoT group. Is that fair enough to say, Lou?
It's the Edge Operating Systems group now. But yes.
Sorry, Edge Operating Systems group. And then I'm going to pivot a little bit more to the center of the room. Hey, there's Roger. And then Levi, if you want to head over that way as well. Okay. This particular panel will be moderated by our own Levi Armstrong. Hello, everyone. So Levi, you may want to get in field of view of the camera and test your mic. With that, I'm going to turn it over to Levi Armstrong. Levi, thanks for moderating this. And our panelists, thank you for making it. Thank you for agreeing to do this virtual in light of the recent changes to travel policies. We appreciate your participation.
Thanks for making the accommodations to do it.
Yeah, definitely appreciate that. Thank you. Sorry we couldn't be there.
Yeah, apologies. Hopefully next time I'll be there.
Hello. Hello. Can you hear me? All right. So I guess start off first question. Why ROS Industrial versus rolling your own software?
Shall I go first?
Sure.
Okay. I think there were two data points that influenced that decision. One of which was, I don't believe we'd actually have an AWS cloud if we didn't have Linux. Can you imagine having to pay $90 to $200 for an OS license for machines that are sitting idle waiting for customers to spin up and use them? That would have just killed our business. Not only the fact that we can add security, we can make performance changes, we own our own destiny. A second data point, you saw the video of Amazon Robotics. I talked with the team that actually started that group, the Keynote, and they shared with me that there was a price point at which they were approached of an OS that they could run on their robot. It's something you and I wouldn't think twice about you spending for lunch, and it was too expensive for them. And that kind of just told me that this is how this is going to play out. Startups will not pick up and pay $10 for an operating system. And then you pan back and you look at the community that's here in ROS Industrial and just ROS Education and ROS users. It's too great to ignore. Open source has won. That's my answer.
Thank you. Yeah. Anybody else want to add anything else?
Sure. I have a little bit of a longer-winded answer if you got a second. I think with this community that you would find that you would agree with the statement that I think the 2020s are the decade of robotics. Is that not a stretch to say? But we're not there yet. The inflection point where the explosion of robotics is still something that has to happen. Looking back over the last 10 years, there are certain prototypical solutions that have led to technology that we have today. 3D printing, Arduino, and even the Raspberry Pi were new concepts 10 years ago. But really, what led to industrial IoT and some of the modern solutions came from the community, came from the maker community. I believe that the maker moment for robotics is coming, and I think that Arduino, or the ROS-2 is actually the Arduino of robotics. It's going to lead to that explosion. We are approaching it from the industrial side because Windows IoT actually has a huge presence in industrial automation. In fact, many, if not most, programmable logic controllers and industrial control systems are actually running Windows today. So it was natural for us to actually say, look, our customers have come to us and said, hey, we really love Windows. We want to bring ROS to our systems. So we started off with, okay, well, what does it take to bring ROS to Windows? As well as what can we do for to help catalyze that maker moment for robotics. So we're starting from industrial to help build the solutions necessary to help catalyze that explosion.
Thank you, Lou. Thank you.
So I can add from the Intel perspective. So for us, I mean, it's different, I guess, in the sense that we usually stop and we don't do applications. That's kind of above the level that we operate in software. However, I mean, the way we see it is I think there's a lot of value leveraging the platform such as ROS and ROS Industrial. There's clearly, you know, as Lou and Roger just mentioned, there's clearly an environment or a community building around it right now. And then it also creates a very interoperable environment so that the engineers you have programming robots are no longer required to program in proprietary environments, and that seems to be a pretty big value for our customers. That way the engineers that are doing the programming no longer have to focus on training in these new proprietary environments and can focus on the production itself. So.
Great, thank you. I guess to lead into that, what have been the challenges in meeting industrial needs related to automation from y'all's perspective?
One more time?
What have been the challenges in meeting industrial needs related to automation from your perspective?
I think one of the challenges we have faced, if you look at the background for ROS, it's largely academic, it's largely research to advance research. The individuals who created these packages have gone on to other jobs. Some are still being maintained and pulled forward, but they haven't reached the quality level. So as a community, we're investing a lot of effort, and that's why I think the role ROS Industrial has to play is actually building commercial-grade packages that will run on top of ROS2 Core. So there's some heavy lifting that we have to do over the next several years, not only to get ROS2 Core at the quality level, and I think it's there, but also all the packages have to move forward so that ecosystem is there for you to tap into. It's there, but it requires a lot of work and some constant effort over the next few years to get it there.
Thank you.
I'd like to add on to that. I completely agree. The quality level is one of the things that we've actually seen with a number of our industrial deployments, where ROS itself is causing some issues, specifically on the ROS1 side. We have been working with a number of companies to transition over to ROS2 for the reliability, but the level of packages isn't there yet. So it's a balance point. Where do you balance between ROS1 and ROS2 for the quality level? On top of that, there's the things that ROS brings to the table, and the solutions that we're building on that are being built on top of ROS, new hardware, new algorithms that are coming online, as well as new usability models and programming models. So that actually has been some of the things that we've been working with a number of customers on.
So yeah, I'll take the question in more general fashion as opposed to just pure ROS. So the area that we've been focusing on here in the industrial team here at Intel, we're looking at trying to remove some of the barriers as the OT environments and IT converge. So many of these challenges are related to creating interoperability and flexibility while still kind of getting that real-time performance in your factory environment. So in regards to robotics, one of the common things that we get from customers is that they'll have two manufacturers or different types of robots from different manufacturers in their factory. And they might have been enabled by like a systems integrator, and they have one person capable of programming robot A, and then they have another person capable of programming robot B. And if they're not on shift, then those robots stay down and the line stays down. So I mean that's a pretty extreme case, but the fact that the education pipeline, as Roger brought up earlier, is clearly in the ROS environment. I think that the advantage of having ROS in your factory helps enable some of that interoperability.
So if you don't mind, I'm going to actually interrupt. This is Matt Robinson. We have an audience question from the online participants, right? So I'm going to actually paraphrase a little bit. But we talk a little bit about driving the robot to, like, say, process on an object that's presented. This particular case talks about, like, in a lot of factory settings, we actually need an intelligent way to hold a lot of different parts. So we talked about either what are the tools? Are we thinking about technologies to understand the presented part and maybe make sure it's not going to move? Like, i.e., is that a simulation question? Or are we missing something in, like, say, the planning for driving things to support parts for a subsequent process that's happening? Maybe, again, maybe that falls into the realm of simulation. I'll turn it over to the crowd here.
I'm going to pass this over to Lou, given his industrial automation and robotics experience. Maybe he has a point of view on this, an informed point of view. Lou, you want to take this one?
Oh, sure. We have been working on a technology that we announced at Embedded World last year called pose detection, which uses the cloud to actually do simulated training sets. So you take a CAD model, photorealistically render it in multiple orientations, and then you train an ML model in the cloud. Then you use the propagation pipeline to push it down to the robot, which is inferenced on the edge. We have a cross-platform technology called Onyx Runtime, which allows you to have hardware accelerated inferencing directly on the robot that uses the model trained from the cloud. Each model represents one particular type of object, and you can spin up multiple parallel solutions so that you get a tagged object identified in three-dimensional space relative to the camera. And with that, you can create tag points on that CAD model that you use for planning the grip solution. So in this way, we have your cloud-enhanced edge and edge native. So you're running actually on the robot. Or if you have an on-prem solution and you want to split the brain of the robot into something that runs directly connected to the robot arm and then something that runs on-prem in an IT closet, you can actually split that and run the hardware inferencing up in the edge on-prem off robot in a constrained environment. So that technology is something that we announced. We're still working on productizing.
So does it have the ability to, I guess, provide feedback on how much, I guess, force or effort is involved in picking up the object or moving the object?
From this, so the solutions that we're working on are purely optical. So it doesn't actually take into account the hardware feedback loop. That would be a separate solution. So this is actually, the solution that we're providing is actually the generation of the pose or publishing of the pose relative to the camera. The gripping behavior would actually need to take into account the pressure or compliance of the part.
Okay, thank you.
Does that answer the question in the audience?
I think that's pretty good.
Yeah.
That's a good one.
Thank you. Also, I guess I have a series of questions. Does anybody in the room have a question they would like to ask the panel at this time?
You're encouraged to step up to the mic.
Okay. Next question. How do you see ROS and more broadly industrial technology development align with the other offerings within your organization?
So we use ROS quite a bit inside of our company. And I think you'll see more robots coming out and actually advertising that they're actually running on ROS. It's not uncommon to see a hybrid model where we're running the safety certified version of our code, running a robot when it's been safety certified, but there's other processing boards running ROS applications on it. So we see it as a valuable tool that we're using, which kind of prompted us, even though, as Lou pointed out, it still is early in this robot revolution that we're going to go through, but we figured out this is valuable enough for us inside the company. Let's go ahead and invest, and that way we have the experience for when it does explode, we'll be there for our customers.
Great, thank you.
So while I can't answer your question directly, I'm going to give you an example and allow you to draw your own conclusions from it. In the past, Microsoft worked on a technology called Microsoft Robot Studio, which was it was about 10 years ago we stopped working on it. But it was very similar to ROS. It shared a common programming models. Simulation was key to the environment. It was integrated into Visual Studio or Microsoft's Visual Studio. The largest single deployment of Robot Studio was MySpace, the social network, because they actually found that the microservices architecture that was presented and the way that messages were handled between processes were actually more ideal for that solution. So ROS itself as a control system for robots is awesome, but can it be a control system for other things?
it's interesting that the two of the groups on the panel are actually in IoT, and I just to Lou's point, this is about programming the edge and the relationship cloud will have with edge and how we deploy programs, manage programs to the edge. Robots are edge-connected devices.
Yeah. I just say there's all three of us are IoT, I think, too, Roger. I'm IoT as well.
I was calling you out as one of the two, sir.
Oh, sorry. I thought you were calling Lou. Sorry.
I was calling you and Lou as IoT. And again,
Yeah.
Fair. All right. My apologies. So to answer your question, Levi, so I think ROS-2 aligns very well with what we're trying to do in industrial solutions. I think it's gonna end up being a very good way for ROS, and it's a good way for robots and AI and CV to combine into one solution. And that's kind of why we got involved contributing to the ROS community over the last couple of years, and bringing in some of these, like the OpenVINO technology that we unveiled last year to help with the AI pipelines, and enable neural nets to run more efficiently, and then added that as a feature set to the ROS-2 community as well. So I mean, I think it's a great solution for where we want to go, and the fact now that we're adding in DDS with the real time, it fits perfectly.
Great, thank you. So I guess related to computing on the edge, I guess for people that have ROS developers back home, how is it, are there resources available that they should take into account when they're developing existing ROS code at their system to make it easier to deploy on the edge? Or do they continue developing the way they've always developed, and then it should just get handled on the edge?
Yeah, as I mentioned earlier in my talk, the edge is becoming an exciting place in terms of the innovation that's taking place for companies that have a stake in it. Microsoft, I know, has a number of edge services and edge offerings, as does AWS. And I think we're going to continue to add more services, more software packages to make edge manageable, to allow you to deploy packages, machine learning models, as you heard Lou talk about. Bottom line is that let somebody else innovate there for you so that you can just draft behind them and piggyback on their innovations. We've got things like Greengrass. It's an example of a secure container that basically runs on a robot. Your application, ROS application, runs inside of Greengrass. It's a secure container. Nobody can hack it. Nobody can actually modify the code. So you get that for free. And you then have a device shadow. You have a robot shadow, basically. And so you can selectively send data from your robot up to the cloud where was its last known location. I got all that for free by building on top of these existing technologies that others are building. I know Microsoft has a rich set of solutions as well that one is going to be able to build on. So I think go do your homework on what's available for you on these offerings to see what best suits your purpose.
Great, thank you.
That was awesome. Thanks for that. I couldn't add to that one.
Unity across our technical community.
Yeah, it's good. How do you see the transition to ROS-2 affecting the industrial community?
I think it's having a transformational effect. Companies that had built and managed their own OSs are, again, we can't have confidence, they're moving to ROS-2. They're taking ROS very seriously now. When they see the logos of the companies that are standing behind it, they listen to what steps are being taken to ensure that the quality is there. We're seeing a lot more buy-in and people leaning in saying, let's talk more about how we can move our robots over to ROS-2. The economics have always been there, but now they're actually seeing there's an ecosystem they can tap into, so they might as well go ahead and port their old application so they can take advantage of these new packages as they come out. I don't think the transition has been complete yet. I think you see people leaning in early, but we want to get to a place where a startup or even a mature company would say, why the heck aren't we using ROS? That's just stupid. I mean, we should be taking advantage of this. Why are we building our own stuff here? We haven't quite seen that point yet, but you are seeing people lean in and say, let's refactor our application and take advantage of ROS. So we are seeing a mind shift. I'll stop there.
Great, thank you.
There is I agree on the mind shift. One of the things that we've encountered with in engaging with a number of companies is I want to use ROS-2, but, and what we'd like to do is try and figure out what that but is and close that gap. And I think the ROS-II Technical Steering Committee is doing a great job in identifying those gaps and closing them. But there is a secondary effect. There's the companies that are producing middleware and hardware that isn't necessarily ROS-II friendly yet. And so our engagements with various middleware providers is how do we actually drive them to produce ROS-II friendly solutions, which also includes our own ROS-II nodes. For example, our machine learning nodes, our hardware nodes, and our Halo nodes as well. Or Halo meaning the circling around all of our solutions for ROS.
So I don't have a lot to add there, other than, it's maybe stating the obvious of, once DDS got added in, I think that really kind of gave the feel that ROS was going to move out of the labs and into the factory floor. So it just, the question that we always got was, is it real, it's great, but it's not real time friendly. And so now, with that addition, it seems people are getting more serious about ROS-II, and it's creating more conversations about it, and there's definitely an increase in activity that we hear as well. So,
I did want to touch on one thing you just said, which is real time. Real time, it means different things. It's kind of a trigger word that it means different things to different people. So we often talk about, so when I talk about real time, I talk about time domains and what different time domains are required for different scenarios. For example, real time from a camera perspective is actually significantly higher than real time from an IMU. So from talking about time domains actually says, okay, are we talking sub-millisecond, millisecond, even second or more time domains, so that you can be more specific about the latency and the throughput for a specific scenario. I know Roger mentioned latency. Phil Spencer is the VP of Xbox, and as they're building the X Cloud, one of the things that they said was, or have identified, is that there's fast twitch games where the milliseconds matter, and those aren't really optimized for that cloud round trip. You need to bring some things closer to the device, which is why the Xbox is not a 100% cloud solution. So latency and throughput are both incredibly important. And I think there is a mythology surrounding certain technologies like 5G that actually don't match reality when it actually is deployed outside of a lab environment. So real time and time domains are going to be more critical as we see bigger adoption and multi-robot collaboration.
Yeah, no, great point. And I 100% agree with you. I regret saying real time now because it's a very overloaded word. And you have to understand the context of when you say real time, you have to make sure that everybody has context to what you mean by real time and what time domain you're talking about. 100% agree. So it becomes a very confusing conversation more often than not. So.
Yeah. More for us, we use the term just in time than real time. Can you get it computed in time for the process that you're doing? I guess so. A lot of these individuals in the room, one of the questions we have as robotics advocates in your company, how do you go about advocating for open source development to your management for those companies that are looking to get involved in the open source community? And how do they approach their management on getting involved in the community from their side?
It was a pretty easy sell for me. Many of our roboticists within the company had come through grad school using ROS. They were quite fond of ROS. They were actually excited to hear that we were going to actually try to get actively involved in contributing to ROS. Amazon has contributed a lot to open source software, but we've been really quiet about it, and that hasn't worked out in our favor. And so they're actually quite okay with us now being publicly talking about our support for ROS as well. And we think it's key. If we're going to get companies to move over to ROS2, they have to see the logos and the people that are standing behind it and see it's a wide range of companies. There's one change we have to make happen though. We have to, when I talk to all the startups that have used ROS1 successfully to run their company and build their robot, they've forked. And they had to because it was educational grade software and they had to harden it and actually make it commercial grade. But they've not been able to contribute back. And in many cases they've said, yeah, we've got some software we actually think would be great to give back to the ROS community, but we've woven it into our custom code and I can't really tease it out on the startup. So we want to get that mentality that ROS2 is the thing, it's commercial grade, and let's all be makers and not just takers, and get the community to start contributing these software packages back that basically don't have value for them, but others could actually take advantage of them. So I think we have a little bit of work to do, and that's why I think being vocal about our support for ROS is key to get this whole transition to take place.
Great.
I can take a stab at that one. With the new CEO came actually a new openness to open source software and contributions back. And while Windows itself is not open source, a lot of the things that we're building on top and in the middle are open source. Not just throw it out there and have a blast with it, but we're actually active, engaged, and contributing. Many of the things that we're building on top of our cloud services are also open source first. And in fact, my manager was the development manager for the subsystem for Linux for Windows, which allows you to run Ubuntu or other distributions natively in Windows and work with solutions inside of it. There's some mismatches on hardware and acceleration, which is one of the reasons why you want to run things natively on Windows if that's something you want to deploy with. But you do get a lot of guarantees when you purchase a copy of Windows, 10-year support, for example. We have some other announcements that we'll talk about during my talk as well around that. But building and contributing is, for the first question is now, can it be open source? Doesn't need to be open source. And that's actually been a tectonic shift internally. So I'm incredibly proud to be working on these solutions.
Yeah, I think for me here, Intel's really two different, I mean, you can say that about a lot of companies, but two different companies. So there's the team I'm on now that is very focused and happy, we're very supportive of open source technology. So, it's very easy sell and it's just, make sure that we do our homework. But I was also, previously I was in the manufacturing organization here at Intel, and maybe that relates to some of the people in the audience where you use a proprietary software because you need somebody to call up when it doesn't work, right? So, and there's, concern with using open source and doesn't always, work, or it's a huge mental barrier, not necessarily a technical barrier to overcome. And I mean, I guess some ideas to kind of work through some of those barriers is that I've seen work is just build a system and kind of build a system. Hopefully they'll come, and show that the open source like ROS is actually working in a factory environment and that you're getting, reliability. And then there's also, show that you can start with open source software and then add your secret sauce to it as well, right? And that it's a way to not be so reliant on the proprietary software that's out there, and relying on those developers and actually being able to do something in-house that you can enable in your factory environment that maybe other companies don't necessarily care about, but there's huge value for your own, and the only way to do it is leveraging that open source software. So.
Great, thank you. So does anybody in the audience have any questions? Or, okay, one in the audience? Yeah, for the people online. Oh.
No? So as a systems integrator, I guess the question I have is how does ROS interface with the traditional, automation control system? Because when you think about putting ROS, machine-centered, or a robot in a traditional factory store, and integrating it to the rest of the line, what's the current state, or how does the communication with the rest of the line happen? What protocols are supported? Your Ethernet, IP, Modbus, any standard communications that are offered?
That could probably be a long discussion. Maybe Lou will have more to add to this as well, but we've seen something as simple where somebody has had, we've got a group inside, we acquired a company for their robotic technology. They want to be part of the ROS ecosystem. One of the first things we did is we actually introduced a ROS node on the robot that basically understands how to speak to their existing API and codes and all the other hardware that's on the robot. So now to the outside world, it looks like a ROS device. They're now refactoring some of their software and partitioning the safety critical stuff that they don't want to recertify and moving other software off ROS bridge. So now you're actually starting to put ROS nodes, a ROS ecosystem to actually complement the functionality of the robot. So there are various architectural patterns that you can use to actually integrate existing software that needs to run a certain way with ROS nodes and to complement it. So there's ways to do it without having to rewrite everything. It's also not uncommon to see robots, frankly, that are running a completely separate board where all the software continues to run on the other board. The resources are reserved for that safety certified software, a separate board which is actually running all of your ROS code as well. So again, there's different patterns that people have done to actually complement ROS-based code in robots with their existing proprietary stacks.
Thank you. So Windows is present actually on quite a number of PLC vendors. I don't necessarily want to name drop, but what they do is they take the core operating system and then they put their SDKs on top of it. And then on top of that are ROS nodes that project through that. So for example, EtherCAT. You can use SOAM as a interface between ROS and EtherCAT so that you can talk to any EtherCAT devices underneath of it. Same thing for Modbus and Profinet and a bunch of other industrial buses. CAT is kind of fascinating. Windows doesn't actually have a CAT stack, so a lot of customers who are producing CAN middleware have their own ROS nodes that sit on top of that, and we've written some documentation on how to talk some non-native buses. When it comes to talking to USB, we have one of the best USB stacks in the world with a number of first-party written USB class drivers, which have their own projections on top of. So whether it's industrial cameras or standard off-the-shelf cameras, there's a way of projecting those buses into ROS. I think that's what you were asking about. So the ROS ecosystem has brought a lot of features with it, and as we ported those things to Windows, the underlying tech has either been projected directly, so it just cross compiles, or there's some minor interrupt that you have to do to make it work on Windows as well.
So I have an addition to add to that. So some of our systems that we've deployed, we've treated in industrial automation, we'll treat ROS as a sensor, depending on the integrator we're working with. And we write the ROS system such that it can easily be detected from PLCs as just another device on their industrial automation system and provide a mechanism for communicating, say, between the PLC and our ROS system for making motion planning requests, vision requests, but from the integrator perspective, it just looks like another Ethernet IP device to the PLC, and we've taken that approach in several of our systems, so it just shows up as another device on the PLC. And then you can operate the same way you typically do with any other Ethernet IP device with communicating back and forth with our ROS systems.
We just published a case study with AVB who at one point has a ROS node to control the ABB robot arms that actually talk to their Robot Studio, which actually runs directly connected to the robot. With ROS on Windows, they're actually able to put ROS and Robot Studio on the same system, so you don't actually have to cross multiple systems. So you can read more about that on our landing page.
Great. Thank you.
Thank you. We got time for 2 more questions? Oh, there we go.
Guys, so I know a lot of you offer solutions for, Amazon has a lot of IoT stuff, and I know, oh, closer to the mic, okay, cool. I know you guys have a lot of IoT solutions, and I'm wondering, it seems like it's very focused on the software, but what about like the hardware, right? When you're in a 1 million square foot warehouse or 2 million square foot warehouse, and you need to communicate to your robots, there's talks of 5G and, I don't know, different bands of Wi-Fi. Where do you guys see that change? How do you see that field changing? Does that make sense?
It does. As I mentioned earlier in my talk, I think this space is going to move fast. I know there's going to be some announcements at reInvent this year about services that make that a lot simpler for people to switch between different types of communication and keep a session going. So if one drops out, we'll be able to just switch over and use the other ones. So I think this is going to be commoditized because that edge, having connectivity to that edge is getting more and more important in industrial settings and home settings and consumer and commercial settings. This space is going to evolve fast, and I think we can draft behind some of these offerings. I wouldn't wave my hand at 5G and say all the problems are going to go away, but it does. 5G does offer things where you can actually set the priority for a message. Like, this is a really important message; it has to get out. Prioritize it. So again, these technologies are just going to become a palette of things you're going to be able to choose from. I think over the next year or two, I think the world's going to change a lot there. In fact, I'll stop.
I agree. One of the things that we see in factories is, even with strong signals, there's always going to be attenuation. So that we talk about radio islands, where you go from island to island, even in a factory that's coated in Wi-Fi. Some of the factories' ceilings are so high that the signal is degraded by the time it hits the floor. And with motors and cages and all the metal moving around, the signal integrity is quite low. So you need to be able to run enough on the robot so that it's safe, can achieve its mission, or at least call for help when it needs some support, and have an operator come to it that creates a micro island that can help it get out of the scenario. So there's a number of partners that Microsoft has all up in the IoT space. I kind of say that IoT is a little bit of a buzzword, and that what we're really talking is embedded solutions, where the internet part is a critical part, but it needs to operate independent of that connectivity. 5G, part of my larger team actually owns our 5G stack, and we're often talking about how does a robot use 5G if you have a deployed cell in a factory, and what does it take to actually flood the factory with enough 5G signal? It turns out that a lot of the really promising bandwidth that you get from 5G won't even pass through a piece of paper. So how is it really going to work on a factory floor? And so it's really critical that between those radio islands that it can operate independently.
Yeah, I mean, so obviously we're working on 5G hardware here at Intel, and kind of what Lou said, we're doing a lot of research and trying to understand our customer use cases to understand how you would employ or deploy in a factory. There's also competing Wi-Fi 6, which also might be a solution too in that space. So you have a couple options there. And then down more, because I think part of your question also was related to hardware. This is also and which I'm assuming is more, controller hardware, PLC hardware as well. We're also working to enable, better solutions on Intel hardware that better leverages some of the features that we've been putting in that are time just say time deterministic features that we've had in our silicon, and we're trying to enable them a little bit better. And you should see some announcements coming from us over the next 3 to 6 months on that. So.
Yeah, and I'm going to come back and talk a little bit about also software. This is going to be a combination of software and the hardware and the service. Something we added to our CloudWatch ROS node. CloudWatch is a way for us to get logs off of a robot. As Lou mentioned, robots are going to become disconnected. So robots disconnected, a feature we added based on customer feedback was that we start using disk space on the robot to cache those logs. And the user can set a limit of how much disk space. As soon as the robot is reconnected, then we can start to upload those logs. Users can set priority for messages. If you have to throw messages away, what should you throw away so that the good logs are kept? One of my customers told me I've got 20 robots on my floor. If they all tried to upload their ROS bags at the same time, the overhead wireless is going to be flooded. So we have a feature in beta right now in fleet management. If we know they're in the same building, we add jitter to their upload. So when they attempt to upload, they're actually not hitting the router at the same time. Again, a combination of software, hardware, and services, I think, are going to solve a lot of these problems.
Great. Thank you, everybody.
Yep, that about wraps up our time, right?
Yep.
I want to thank our panelists, Josh Heppner with Intel, Lou Amadio, Microsoft, and Roger Barga with the Amazon Web Services. Everybody.
Thank you.
And of course, our moderator, Levi Armstrong. Thanks, Levi. So we've got a nice bevy of food outside. I'm sorry you guys are going to miss out. It's San Antonio fajitas.
Oh.
So for those who were here yesterday, fajitas, we should have coordinated. But anyways, hopefully it was an eventful morning. I'll start haranguing or corralling everybody when we get ready for our keynote speaker, which will be a little bit of period of time after we release for lunch. The food is all set up outside, so feel free to talk amongst yourselves, get to know the people here. Roger, we're going to be here in person. Hey, you guys can take a break, I guess, or actually, I guess, since log back in for the keynote. But Josh and Lou, thank you for participating remotely.
No, thank you, and I'm really sorry we couldn't be there. I don't know if you had heard about the number of cases that have exploded recently in Washington. I'm probably saving you. So.
Thanks, Lou. I appreciate it. And Josh, thank you. I look forward to seeing you guys both soon.